Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch, Episode 1. In this episode, we're going to start learning Linux from the project Linux from Scratch. I am in the main page or the welcome page of Linux from Scratch. So uh, let's get to know what is Linux from Scratch project. Linux from Scratch is a project that provides you with step-by-step instructions for building your own custom Linux system entirely from source code. So currently, the Linux from Scratch organization consists of the following subprojects. LFS, Linux from Scratch, is the main book, the base from which all other projects are derived. BLFS, Beyond Linux from Scratch, helps you extend your finished LFS installation into more customized and usable system. ALFS, Automated Linux from Scratch, provides tools for automating and managing LFS and BLFS builds. Hints, the Hints project is a collection of documents that explains how to enhance your LFS system in ways that are not included in the LFS or BLFS books. Patches, the Patches project serves as a central repository for all patches useful to an LFS user. LFS LFS Editor's Guide, a document that describes the LFS development process. Museum, copies of ancient LFS and BLFS versions. Okay, now we will start from the LFS project. Okay, so let's read through this page. What is LFS from scratch? Linux from scratch is a project that provides you with step-by-step instructions for building your own customized Linux system entirely from source. Why would I want an LFS system? Many wonder why they should go through the hassle of building a Linux system from scratch when they could just download an existing Linux distribution. However, there are several benefits of building LFS. Consider the following. LFS teaches people how a Linux system works internally. Building LFS teaches you about all that makes Linux tick, how things work together and depend on each other. Most importantly, how to customize it to your own tastes and needs. Building LFS produces a very compact Linux system. When you install a regular distribution, you often end up installing a lot of programs that you would probably never use. They're just sitting there taking up precious disk space. It's not hard to get an LFS system installed under 100 MB. Does that still sound like a lot? A few of us have been working on creating very small embedded LFS systems. We installed a system that with just enough to run the Apache web server. Total disk space usage was approximately 8 MB. With further stripping, that can be brought down to 5 MB or less. Try that with a regular distribution. LFS is extremely flexible. Building LFS could be compared to a finished house. LFS will give you the skeleton of the house, but it's up to you to install plumbing, electrical outlets, kitchen, bath, wallpaper, etc. You have the ability to turn it into whatever type of systems it needs to be customized completely for you. LFS offers you added security. You will you will compile the entire system from source, thus allowing you to audit everything if you wish to do so and apply all the security patches you want or need to apply. You don't have to wait for someone else to provide a new binary package that fixes security holes. Often, you never truly know whether a security hole is fixed or not unless you do it yourself. What can I do with my LFS system? A by the book LFS system is fairly minimal, but it is designed to provide a strong base on which you can add any packages you want. See the BLFS project for a selection of commonly used packages. Okay, who's who? Great, I think this is important to know who is involved in the project. Project creator, Gerard Peakmoss. Managing editor, Bruce DeBoss. Editor, okay, we have a bunch of editors. Ken Moffat, Perry Labasti, DJ Lucas, Douglas R. Reno, Thomas Ripple, Tim Tassonis, Xi Ruyao, plus numerous people who contributed to the book and its side projects. So from this book, what is expected is we will learn more internals of Linux, how it works, and uh, the aim is, let's say, to learn how Linux works in a detailed way. Okay, and let's try downloading the book so that we know which version we will be using for the entire series of Linux from scratch. Okay, so we will be using version 11.0, and which was published, the stable version which was published in September 1st, 2021. Okay, the table of contents, it's previous forward. So let's go through the table of contents and learn what this book is going to offer. It starts with introduction, how to build LFS system, what's new since the last release, what's changelog, resources, and help. The next section is preparing for the build, preparing the host system. Introduction, host system requirements, building LFS in stages, creating a new partition, creating a file system on the partition, setting the LFS variable, mounting the new partition, packages and patches. Introduction, all packages needed patches. Final preparations, introduction, creating a limited directory layout in LFS system, adding the LFS user, set up the environment, about SBUs, about the test suites, building the LFS core toolchain and temporary tools, important preliminary materials, introduction, toolchain, technical notes, general compilation instructions. Okay, compiling a cross toolchain. So here we are going to, I think we're going to see how do we compile bin utils GCC Linux. I think this is 5.13.12 is the version of Linux kernel that we would be using. Then glibc lib standard C plus libstd C++ from GCC 11.2.0. And the next sixth chapter is about cross compiling temporary tools. There are a lot of tools which we will be compiling by ourselves, entering the ch root and building additional temporary tools. And then we will learn about building the LFS system, installing basic system software. Okay, there are a lot of softwares that we would need, and it lists all. System configuration, I think we will learn about LFS boot scripts, device overview and module handling, managing devices, general network configuration, system view boot script, usage and configuration, the bash shell startup files, creating the etc input rc file, etc shell files, making the LFS system bootable. Okay, and this is the 11th chapter is the end. So I think here he will conclude about the LFS and the appendices. So as we see, here we're going to see a lot of different modules that are required for building Linux or to make Linux work. So what we would be doing is we will also see what each modules are. Maybe we browse through internet and find out what each module is, and then we will build each of these modules for the LFS build. Okay, let's learn through preface. Forward. Okay, I think he here the author is explaining why he started the LFS project and a little bit background on this. My journey to learn and better understand Linux began in 1998. I had just installed my first Linux distribution and had quickly become intrigued with the whole concept and philosophy behind Linux. There are always many ways to accomplish a single task. The same can be said about Linux distributions. A great many have existed over the years, some still exist, some have morphed into something else, yet others have been relegated to our memories. They all do things differently to suit the needs of their target audience because so many different ways to accomplish the same end goal exist. I began to realize no longer had to be limited by any one implementation. Prior to discovering Linux, we simply put up with issues in other operating systems as you had no choice. It was what it was, whether you like it or not. With Linux, the concepts of choice began to emerge. If you didn't like something, you were free, even encouraged to change it. I tried a number of distributions and could not decide on any one. They were great systems in their own right. It wasn't a matter of right and wrong anymore. It had become a matter of personal taste. With all the choice available, it became apparent that there would not be a single system that would be perfect for me. So I set out to create my own Linux system that would fully conform to my personal preference. To truly make it my own system, I resolved to compile everything from source code instead of using precompiled binary packages. This perfect Linux system would have the strength of various systems without the perceived weakness. At first, the idea was rather daunting. I remained committed to the idea that such a system could be built. After sorting through issues such as circular dependencies and compile time errors, I finally built a custom built Linux system. It is fully operational and perfectly usable like any other Linux system out there at the time. But it was my own creation. It was very satisfying to have put together such a system myself. The only thing better would have been to create each piece of software myself. This was next best thing. As I shared my goals and experience with other members of Linux community, it became apparent that there was a sustained interest in these ideas. In- It quickly became plain text such as custom built Linux serve systems serve not only to meet user specific requirements but also serve as an ideal learning opportunity for programmers and system administrators to enhance their existing Linux skills. Out of this broadened interest, the Linux from Scratch project was born. This Linux from Scratch book is the central core around that project. It provides the background and instructions necessary for you to design and build your own system. While this book provides a template that it will result in a correctly working system, you're free to alter the instructions to your suit yourself, which is an important part of this project. You remain in control. We just lend a helping hand to get you started on your own journey. I sincerely hope you will have, excuse me, I sincerely hope you will have a great time working on your own Linux from scratch system and enjoy the numerous benefits of having a system that is truly yours. Gerard Beekmans, Gerard at linuxfromscratch.org. Okay, so here the very important thing is the drive what made this Linux project exist. For us, I think, at least for me, what is important is to learn important concepts of Linux, how it works. I hope this book fulfills that idea of learning Linux completely, or at least to have an idea of what Linux really is. Audience, there are many reasons why you would want to read this book. One of the questions many people raise is why go through all the hassles of manually building a Linux system from scratch when you can just download and install an existing one. One important reason for this project's existence is to help you learn Linux systems works from inside out. Building an LFS system helps demonstrate what makes Linux tick, how things work together and depend on each other. One of the best things that this learning experience can provide is the ability to customize a Linux system to suit your own unique needs. Another key benefit of LFS is that it allows you to have more control over the system without relying on someone else's Linux implementation. With LFS, you are in the driver's seat and dictate every aspect of the system. LFS allows you to create very compact Linux systems. When installing regular distributions, you are often forced to install a great many programs which are probably never used or underused. These programs waste resources. You may argue that with today's hard drives and CPUs, such resources are no longer consideration. Sometimes, however, you are still constrained by size considerations, if nothing else. Think about bootable CDs, USB sticks, and embedded systems. These are areas where LFS can be beneficial. I think being embedded Linux developers, we need to know how do we how do we design embedded Linux to suit for our own needs. I think this book is going to help us a lot. Another advantage of a custom Linux system is security. By compiling the entire system from source code, you are empowered to audit everything and apply all the security patches desired. It is no longer necessary to wait for somebody else to compile binary packages that fix a security hole. Unless you examine the patch and implement it yourself, you have no guarantee that the new binary package was built correctly and adequately fixes the problem. The goal of Linux from scratch is to a compile build a complete and usable foundation level system. If you do not wish to build your own Linux system from scratch, you may nevertheless benefit from the information in this book. There are too many other good reasons to build your own LFS system to list them all here. In the end, education is by far the most powerful reason. I think that's why we are here. As you continue in your LFS experience, you will discover the power that information and knowledge truly brings. LFS Target Architectures. The primary target architecture of LFS are AMD Intel x86 32-bit and x86 64-bit CPUs. On the other hand, the instructions in these books are also known to work with some modifications with the PowerPC and ARM CPUs. To build a system that utilizes one of these CPUs, the main prerequisite, in addition to those on the next page, is an existing Linux system such as an early LFS installation, Ubuntu, Red Hat, Fedora, SUSE, or other distribution that targets the architecture that you have. Also note that a 32-bit instruction distribution can be installed and used as a host system on a 64-bit AMD Intel computer. For building LFS, the gain of building a 64-bit system compared to 32-bit system is minimal. For example, in a test before build of LFS 9.1 on a Core i7 4790 CPU based system using 4 cores, the following statistics were measured: architecture, build time, build size. 32 for 32-bit, the build time is 239.9 minutes with the build size of 3.6 GB, and a 64-bit machine 233.2 minutes and 4.4 GB. So not a big improvement with respect to timings, and also it takes a little bit higher size as well. As you can see, on the same hardware, the 64-bit build is only 3% faster and 22% larger than the 32-bit build. If you have planned to use LFS as LAMP server or a firewall, a 32-bit CPU may be largely sufficient. On the other hand, several packages in the BLFS now need more than 64 GB of RAM to be built and or to run, so that if you plan to use LFS as a desktop, the LFS uses recommended build on a 64-bit system. The default 64-bit build that results from LFS is considered a pure 64-bit system. That is, it supports 64-bit executables only. Building a multi-lib system requires compiling many applications twice, once for a 32-bit system and once for a 64-bit system. This is not directly supported in LFS because it would interface with the educational objectives of providing the instructions needed for a straightforward base Linux system. Some LFS or BLFS editors maintain a fork of LFS for multilib, which is accessible at this website, which we will see in the later episodes. But it is an advanced topic. Okay, prerequisites. Building. Okay, maybe before that, I would want to uh, mention here that for for the reason uh, I would be using a virtual machine to build an LFS with uh, this configuration. CPU, what I'll be using is two CPUs, two cores, two CPUs with uh, a memory of 8 GB. So this is because I have tried doing LFS once and I crashed the host system. In my case, the host system is Ubuntu, and I don't want to do that again. So that is the reason I have chosen to use a virtual machine. In the virtual machine, I am using, or I have installed uh, Bodhi Linux. So this is basically uh, it's forked out of Debian or distribution. It's similar to Ubuntu, so that is the reason I have chosen both the Linux. Let's see. And the desktop looks like this, both the Linux, and it has similar uh, user interface or similar command interfaces as Debian, Debian or Ubuntu. So that is the reason I have chosen this because I am familiar with Ubuntu distribution. Okay, so let's move forward. Prerequisites. Building an LFS system is not a simple task. It requires a certain level of existing knowledge of Unix system administration in order to resolve problems and correctly execute the commands list. In particular, as an absolute minimum, you should already have ability to use command line shell to copy or move files and directories, list directories and file contents, change the current directory. It is also expected that you have a reasonable knowledge of using installing Linux software. Because the LFS book assumes at least the basic level of skills, the various LFS support forums are unlikely to be able to provide with much assistance in these areas. So you will find that your questions regarding such as basic knowledge will likely go unanswered, or you will simply be referred to the LFS essential pre-reading list. Before building an LFS system, we recommend reading the following: software building how-tos. Let's see what it is. This is a comprehensive guide to building and installing generic Unix software packages under Linux. Although it was written some time ago, it still provides a good summary of basic techniques needed to build and install software. Okay, well, I have gone through this, and anyway, since I am aware of how to build and install software packages for Linux, so I'll not go through this, and as we move in the LFS, you would eventually learn this as well. Of course, as and when we need help, we can refer the online community. We can go to online community for the help. And I have uh, experience with working with Linux, so this is not a problem. And I have in my channel, I have uh, videos on some of the basic Linux commands, how to use. So I'll provide those links in the description as well. The beginner's guide to installing from source. So this is, I think, one other link where how do we install software from the source code. So which is again we're going to face this in the installation process. So no worries. So as we go, we will learn all of this step by step. So that's the reason I'm not going to go through this completely. And this guide provides a good summary of basic skills and techniques needed to build software from source code. Okay, LFS and standards. The structure of LFS follows Linux standards as closely as possible. The primary standards are POSIX 1 2008, File System Hierarchy Standard FSH version 3.0, Linux Standard Base version 5.0, which is I think formulated in 2015. The LSP has four separate standards: core, desktop, runtime languages, and imaging. In addition to generic requirements, There are also architecture specific requirements. There are also two areas for trial use: GTK3 and graphics. LFS attempts to conform to the architectures discussed in previous sections. So that means the LFS would attempts to conform to POSIX, FSH, and LSB standards. Maybe we'll just go through and learn what it is briefly. Of course, we're not going to. Uh, the idea is to build system. The idea is just understand what it is, what the standards are. POSIX is simultaneously it's an IEEE standard, the open group technical standard for base specifications. Okay, so basically, I suppose it is IEEE standard. Okay, let me not go through this. The following areas are outside the scope. Okay, so what is the scope of this POSIX standard is general terms, concepts, and interfaces common to all volumes of the standard, including utility, conventions, and C language header definitions are included in the basic definitions volume. Definitions for system, service functions, and subroutines, language-specific system services for C programming language, function issues including portability, error handling, and error recovery are included in the system interface volume. Definitions for a standard source code level interface to command interpretation services, a shell, and and a common utility program for applications. Application programs are included in the shell and utility volume. Extended rationale that did not fit well into the rest of the document structure, which contains historical information concerning contexts of POSIX 1 2017. Why features were included or discarded by the standard developers is included in the rationale. It's an informative volume. Okay, so this basically outlines how your system uh, should should consist, what system should consist, or it basically says some standards on the language and uh, the APIs and headers, that information. So I think let's go to file system hierarchy standard. Okay, let me not go completely into it. So those who are interested can uh, refer. So just let me read this abstract. This standard consists of a set of requirements and guidelines for file and directory placement under Unix-like operating systems. The guidelines are intended to support interoperability of applications, system administration tools, development tools, and scripts, as well as greater uniformity of documentation for these systems. Basically, this standardizes the file systems. The LBS specification is more about uh, how your Linux base should look. So it has different functional areas. The LBS it's common. It says like generic. There are common. The functional areas are common: core, desktop, runtime languages, imaging, trial use is GTK3 and graphics. So probably will not go deep into all of this. So who are interested can go through this and learn more about it. So as and when we are required, maybe we will come back in this series. Okay, so here the packages supplied by LFS needed to satisfy the LSB requirements. So say for example, if you're building for LSB core, these are all the packages that are required. It should include bash, bc, binutils, core utils, diffutils, file, find utils, gawk, grep, gzip, m4, mandb, ncn cursus, proc ps, psmis, misc, sed, shadow, tar, util, linux, zlib. And for lsp desktop and lsp runtime language is perl. lsp imaging, basically in this category there is nothing. So packages supplied by BLFS needed to satisfy the LSP requirements. Okay, these are the packages. These are the core components, the desktop components that you should have. The runtime languages for BLFS is Python, libx, ML2, libx SLT. LSP imaging, you should have CUPS, cups, filters, script, sane, and for LSP GTK3 you should have GTK plus 3. Packages not supplied by LFS or BLFS needed to satisfy the LFS requirements. For LSP desktop, we have Qt4, but Qt5 is provided. Qt4 is basically not there or not supplied. Okay, so rationale for packages in the book. As stated earlier, the goal of LFS is to build a complete and usable foundation level system. This includes all packages needed to replicate itself while providing a relatively minimal base form from which to customize a more complete system based system based on the choices of the user. This does not mean that LFS is the smallest system possible. Several important packages are included that are not strictly required. The list below documents the rationale for each package in the book. Okay, so basically when we build for package, each package we would see in detail why it is, what it is, and who developed and other things while it is building. So, okay, the ACL package. This package contains utils to administer ACE access control list, which are used to define more fine-grained discretionary access rights for files and directories. ATTR. This package contains programs for administering extended attributes on file objects. Autoconf. This package contains programs for producing shell scripts that can automatically configure source code from a developer's template. It is often needed to build a package after updates to the build procedure. Automake. This package contains programs for generating makefiles from a template. This is often needed to rebuild a package after updates to the build procedures. Bash. This package satisfies an LSB core requirement to provide Bone shell interface to the system. It was chosen over other shell packages because of its common usage and extensive capabilities beyond basic shell functions. BC. This package provides an arbitrary precision numeric processing language. It satisfies requirements needed when building a Linux kernel. Binutils. This package contains a linker, an assembler, and other tools for handling object files. The programs in this package are needed to compile most of the packages in the LFS system and beyond. by Sun. This package contains the GNU version of YACC, yet another compiler needed to build several other LFS programs. bzip2. This package contains programs for compressing and decompressing files. It is required to decompress many LFS packages. Check. This package contains a test harness for other programs. Core utils. Core utils. This package contains a number of essential programs for viewing and manipulating files and directories. These programs are needed for command line file management and are necessary for installation procedures for every package in LFS. Data GNU. This package contains a framework for testing other programs. Diffutils. This package contains programs that show the difference between files and directories. These programs can be used to create patches and are also used in many packages. Build procedures. ETF E2SP orgs. This package contains utils for handling the ext2, ext3, and ext4 file systems. These are the most common and thoroughly tested file systems that Linux supports. udev. This package is a device manager. It dynamically controls the ownership, permissions, names, and symbolic links of devices in the dev directory as devices are added or removed from the system. Expat. This package contains a relatively small XML parsing library. It is required by the XML parser Perl module. Expact. This package contains a program for carrying out scripted dialogues with other interactive programs. It is commonly used for testing other packages. File. This package contains a utility for determining the type of a given file or files. A few packages need it in their build scripts. Find utils. This package contains programs to find files in a file system. It is used in many packages build scripts. Flex. This package contains a utility for generating programs that recognize pattern in text. It is the GNU version of the lexical analyzer program. It is required to build several LFS packages. GAWK. This package contains programs for manipulating text files. GCC. This package is a GNU compiler collection. It contains C++ compilers as well as several other not built by LFS. GDBM. It is GNU database manager library. It is used by one other LFS package, ManDB. Gettext. This package contains utilities and libraries for internationalization and localization of numerous packages. glibc. This is the main C library. Linux programs will not run without it. GMP. This package contains math libraries that provide useful functions for arbitrary precision arithmetic. It required to build GCC. gpuf. This package contains a program that generates a perfect hash function from a key set. It is required for edev. grep. This is a searching through file. This is required for searching through files. These programs are used by most packages, build scripts. graph. This package contains programs for processing and formatting text. One important function of this program is to format man pages. grub is a grand unified bootloader. This is one of several bootloaders available, but this is most flexible. gzip. this compressing and decompressing file. It is needed to decompress many packages in LFS and beyond. INO etc. This package provides data for network services and protocols. It is needed to enable proper networking capabilities. Initils. This package contains program for basic network administration. Int int tools. Int tools. This package contains tools for extracting translational strings from source files. iprot iprot2. This package contains programs for basic and advanced IPv4 IPv6 networking. It was chosen over the other common network tools packages, nettools for IPv6 capabilities. KDB. This package contains key table files, keyboard utils for non-US keyboard, and a number of console fonts. Kmod. This package contains programs needed to administer Linux kernel modules. Less. This package contains a very nice text file viewer that allows scrolling up or scrolling down when viewing a file. It is also used by ManDB for viewing man pages. libcap. This package implements the user space interface to the POSIX 1003.le capabilities available in Linux kernel. libelf. The utils project provides libraries and tools for ELF files and dwarf data. Most utils in this package are available in other packages, but the library is needed to build the Linux kernel using the default and most efficient configuration. lib libffi. This package implements a portable high-level programming interface to various calling conventions. Some programs may not know at the time of compilation what arguments are to be passed to a function. For instance, an interpreter may be told at runtime about the number and type of arguments used to call a given function. libffi libffi can be used in such program to provide a bridge from interpreter program to compiled code. libpipeline. The pipeline package contains a library for manipulating pipelines of subprocess in a flexible and convenient way. It is required by the ManDB packages. libtool. This package contains the GNU generic library support script. It wraps the complexity of using shared libraries in a consistent portable interface. It is needed by the test suite in the other LFS packages. Linux kernel. This package is the operating system. It is the Linux in GNU Linux environment. M4. This package contains general text macro processor used as a build tool for other programs. Make. This package contains a program for directing the building of packages. It is required by almost every package in LFS. ManDB. This package contains programs for finding and viewing man pages. It was chosen instead of the man package due to superior internationalization capabilities. It supplies the man program. Man pages. This package contains the actual contents of the basic Linux man pages. Meson. This package provides a software tool for automating the building of software. The main goal for Meson is to minimize the amount of time that software developers need to spend configuring their build systems. It is required to build system D system D as well as many BLFS packages. MPC. This package contains functions for arithmetic of complex numbers. It is required by GCC. MPFR. This package contains functions for multiple precision arithmetic. It is required by GCC. Ninja. This package contains a small build system with a focus on speed. It is designed to have its input files generated by a high-level build system and to run builds as fast as possible. This package is required by Mason. Ncurses. This package contains libraries for terminal independent handling of character screens. It is often used to provide cursor control for a menuing system. It is needed by a number of packages in LFS. OpenSSL. This package provides management tool and libraries related to cryptography. These are useful for providing cryptographic functions to other packages, including the Linux kernel patch. This package contains a program for modifying or creating files by applying a patch file typically created by the diff program. It is needed by the build procedure for several LFS packages. Perl. This package is an interpreter for runtime language Perl. It is needed for the installation and test suites for several LFS packages. Package config. This package provides a program that runs metadata about installed library or package. Proc psng. This package contains programs for monitoring process. These programs are useful for system administration and are also used by LFS boot scripts. psmic. This package contains programs for displaying information about running process. I think this is the command ps. These programs are useful for administration. Python 3. This package provides an interpreted language designed philosophically so that has a design philosophy that emphasizes code readability. Readline. This package is a set of libraries that offers a command line editing and historical capabilities. It is used by Bash. ACD. This package allows editing of text without opening it in a text editor. It is also needed by most LFS packages configure script. Shadow. This package contains programs for handling password in a secure way. syslogd. This package contains programs for logging system messages, such as those given by kernel or daemon processes with unusual events when unusual events occur. sysvinit. This package provides the init program, which is the parent of all process on the Linux system. tar. This is the tar. This package provides the archiving and extraction capabilities of virtually all packages used in LFS. TLC. This package contains tools command language used in many test suites in LFS packages. Text info. This package contains programs for reading, writing, and converting info pages. It is used in the installation procedures of many LFS packages. Util Linux. This package contains miscellaneous utility programs. Among them are utilities for handling file systems, consoles, partitions, and messages. Vim. This package contains an editor. It was chosen because of its compatibility with the classic VI editor and its huge number of powerful capabilities. An editor is very personal choice for many users and may other editor would be substituted if desired. XML parser. This package is a Perl module that interfaces with XPath. xzutils. This package contains programs for compressing and decompressing files. It provides the highest compression generally available and is useful for decompressing packages in the XZ or LZMA format. zlib. This package contains compression and decompression routines used by some programs. zstd. This package contains compression and decompression routines used by some programs. It provides high compression ratios and a very wide range of compression or speed trade-off. I think we will end this session with this with this information of rationale for different packages that are used in LFS. So that's it for this session. I look forward for the the next one where we continue uh, with the Linux from scratch. Thanks for watching. Please do support by subscribing to this channel. Please share this video with other Linux enthusiasts. Please comment for suggestions or feedbacks. Thanks for watching.